No, no. We're just going to do dividing, okay, for this, okay? So what does 3 to 20 mean, first of all? 3. Yes, there's 23s on the top, right? What does 3 to 8 mean? Yeah, so there's 8 3s. So there's 23s on the top, there's 8 3s on the bottom. We divide something, all it means is get rid of them. Okay, so all that's going to happen for the 3s is you're going to subtract them. Right, because there's 8 less. You know what I mean? You're getting rid of 3 for 20 for that. If you want to go that second line, go right ahead. Okay, well that's just a subtraction of where it comes from. Not coordinates, by the way. I am good. Okay, let's keep going here. Sorry? Minus 50. That X is just going to be 15 minus 6. Yes. Ask me this question, say what? Say on that? Go ahead. X9, good. Yeah, so all we did for this was 15 minus 6. Right, there's 15 X's on the top and 6 in the denominator.
What happened if your first number is less than second?
Oh, yeah, we'll do that next. I didn't have time to do that on Friday, but we'll do one of those right here. Okay, we're looking at the concept like this, the Y's. What we're doing here, there's just more X on the top and on the bottom. And we ask a good question, what if the denominator is bigger? I'll talk about in a second. Alright, next for the Y's. Go ahead. That's supposed to be 94, but yeah. That's what I can't unless I see exceptions to 6. Okay, 2 last things we're going to do on the top exponents here. Okay? The question that Leah said was, let's say it's something like this. Oh, goodness gracious. Okay, let's just know the question. What happens there? What does that mean? Yes.
There's 2 X's on the top, on the numerator, and 3 X's at the denominator.
Very good. So there's 2 X's up here, and there's 3 X's here. Okay. Someone who's brave here. I believe this. Someone else is brave. Go ahead.
Is it negative?
Yeah, this will be negative 1. Using our power rules here, this is just going to be X to the 2 minus 3, which is X to the negative 1. Well, it's X to the negative 1. What does that mean over here, though? What does that mean on the right-hand side? You guys, if you're zoning me out, please zone in, guys. Okay, we got 5 months left together. Okay? Yes. Let's try. Okay. So help me. What does that mean on the right-hand side? Yeah, cross the right. I'm just going to start crossing. Okay? There's a cross. There's a cross. So I'm not going to 1x in the denominator. What's in the numerator? Nothing. Close or nothing? 1. Yes? 1. Okay, so you're just showing us that a negative exponent just means that there's more x's in the denominator. You write that down here. A negative exponent means more x's in the denominator than numerator. Okay. And one more we're going to do here, and we're going to get away from exponents for a bit. So essentially, you're just dividing, there's when you get rid of 2 from the top, 2 from the bottom, so you're still left with 1 at the bottom, and then using our subtraction rules, you're just doing 2 minus 3. So minus 1.
That was the top and bottom, but what's the denominator?
So,
If we are thinking over 6, if I took 6 from top and bottom, but since 2 and 3, we took 2.
well, just what was, because what happened was, right, but what happened was here, we sort of did that. You take away, okay. What you pick, the problem is if you take away 3, you're left with 1 less, right? Because there's only 2 in the top, after you get the negative 1 part, right? So the way I just said is get rid of 2 2's, so I have 2 x's, and you're left with 1 leftover x in the bottom, and then nothing in the numerator. Okay.
So, if you have negative 1 over x over
Yeah, I'm not trying to.
Where did you get the positive one for X?
Oh, they just mean the same thing. I'm just sort of doing this in two different ways here. This on the left-hand side is my explorer rules, where the explorer is just, just the numerators subtracted on this, 2 minus 3 is equal to 1. Okay, over here is just a little red and expanded form. Right, so x squared is just x times x cubed is x times x. Get rid of 2x's from the numerator and 2x's from the denominator, and I'm left with an x in the denominator. And then there's nothing in the numerator, so it's just 1. Okay. So just 1 over x. 1 over x is the same as x. Either one's okay. If I get one like this, either one's okay. I want to go through one more. I want to put a star beside this one. Okay. I'm going to start with Julia first. Okay, because Julia is a master of her exponent rules. I don't know if you guys know this. Julia, using your exponent rules, what is 4 cubed divided by 4 cubed equal to? No. 1 to 0, right? Everything is 1 to 0, right? 3 minus 3. We actually have to keep that in now. Why would she say 4? That's incorrect. Well, let's try to say 4. Why is just plain old 4 incorrect? Yeah, 1. Okay. Now, 4 to 0, I'm going to do this in expanded form. Actually, this in calculator form. What's 4 cubed? The same as in calculator form. So, I'm going to calculate. 4, 16, let's go to the other. 4. Okay, what's 64 divided by 64? 4? Come on. Weird. Okay, so what I've just shown is that anything to the power of 0 equals 1. That's cool. Okay. So if I say to you 2.29492993 with a 0, there's an equal. Thank you. If I say x squared, x4, x6, x8, all to 0, it equals. Thank you. Anything is 1. If I say negative pi squared x394 to the 0, it equals. Thank you for playing along. Okay, right? Anything to the power of 0 equals 1. So I say the hand raised up there. Joe, was that you?
Yeah, I'm a little confused where you're adding the exponents again.
Yeah, so when you add the exponents, it's going to be multiplied. Okay, so adding the exponents would be, adding the exponents would be one like this. Okay, so when you're multiplying like this would just be 264. Okay, and finally, the only other one we didn't actually go through is one like this. X cubed y to the 10th squared would be like x to the 6, y to the 1. I'm sort of hit every exponent rule there today. I can have that. Yeah.
You know, that's not quite sure why we do that. No, why do we multiply 4? Why do we multiply 4 things for adding it?
This one here, you mean?
No, on the top right.
Oh.
No.
Oh, I just need to get a quarter of power of it. Okay, I didn't have to, the reason I did that is because I would have done, the other way I could have shown this is just 4 times 4 times 4, all over 4 times 4 times 4, which everything crosses out and you're left with 1. And I got the other way, all the way I could have shown. Okay, I'm going to stop this video and I want everyone to put their heads on their desk today, right now.